Alright guys, welcome back. So let's talk about how we can populate our grade to our faces. Okay, now there are kind of like different ways. One thing we can try is do this and do create a for each primitive. Okay, and this for each loop, if you are familiar with programming, you know this is going to be looping through every primitive, right? Every time you go through the loop, you're looping through one primitive. Okay, let's create a null node just to be able to visualize it. Toggle the null down, you can see we're seeing only one face, right? You can go here to the for each and check on the single path. You can drag this thing to, go to every individual loop. We can see it's basically go to different faces. Alright? And then we have our grade and we have that. And there's a node called match size. Okay. And geometry to move, and then our primitive and result goes to there. And take a look. You can see now we're matching it to there, right? You check off the single pass now. You can see we're matching it there. Okay. Alright. In the matching, there is also a scale to fit, which is perfect, and that's going to scale it to our faces, basically. But there's a problem. Our face is kind of like having the Y flattened, so we're going to say, okay, no Y, just scale the other two, but the Y has to be different in this case, right? So we're going to go create another transform node. Okay, and we can define the size Y ourselves, right? Something like 0.1 or whatever. Right, now we are successfully populating our grade, our faces on our faces, basically, right? And name this for each loop match grid begin. Let's copy that and match grid end. Cool. Right, that's one way that we can populate our thing. The good thing about this setup is that it doesn't care how big your grid is, right? If you go here and say our grid is like 20 times bigger, it doesn't care. It's gonna be able to squeeze it in anyways, right? So it's kind of like really cool. All right, so let me go back to the grid and tell it to not be that big. I like the value of 5 in this case. Go back up. Alright, so yeah, we have the grid populated like this. Now we can talk about what's happening to the internal. Alright. So for the internal, we wanted to do something more fun. Because I don't want it to say... Yeah, there's one more thing we can do actually. For the edge here, I want the edge to be smaller, so I'm going to do another subdivide to get smaller grid. So subdivide here, we're going to say linear. Right, again, the result will be just smaller grid now populated over here. Okay, and that means the uniform scale will be even smaller. Now this number is arbitrary, right? You could have like a parameter to control it. Okay, so yeah, let's actually do that. I'm gonna go create a null node. Okay, and then for the null node, I'm gonna go. You know what? Let's actually make a digital asset later on. I think that's better. Actually, we can test it in the game engine or whatever. Okay, so yeah, we have this, and let's move on to the internals. Right, the internals could be more fun, like what I said. Because see, that's that. Oh, those are empty spaces. Well, okay. So yeah, this is correct then. For the internals, I wanted to somehow merge them in various random ways so that I don't have a bunch of grade. Instead, I have a bunch of bigger platforms, okay, in a random way. Right, how do we do that? Well, we have used the for each primitive here. Let's just use it again here to go over the primitives. But this time, we're going to do a for each number. The for each number is the most generic for loop. What it does is basically looping through a certain amount of times, right? We're gathering 10 times this time. It's going to do 10 times. And drag this over here to the input. Okay, now take a look at the final result and take a look at the point numbers, you can see we get a whole lot of things, right? This is like 3,000 points because we're basically doing 10 times and the result is merging every time's result together. So it's gonna merge 10 of this input together as the final result. Now that's not what I want, right? I'm gonna say instead of merging, I'm gonna say I'm gonna feed back every iteration. So once through this once, the first iteration's result will be the second, will be the start of the second iteration. You have to also check one thing here. Go to the for each and say I'm gonna fetch the feedback. Okay, so we went through the first iteration. We do something in the middle. When the first iteration over, it's gonna feedback that result, and that result is gonna be fetched by this node. So it's fetching that feedback, and then start from there and do the second loop and keep on going, right? So we're keeping on doing something to this grid until we're happy, right? So it's fetching feedback, right? But when there is no feedback, it's gonna fetch the input. So the first time, the first iteration, it's still gonna read our grade. So that's why even it's fetching feedback, it's gonna fetch the input the first time. Okay, cool. I'm gonna call this guy populate grade. Not populate. Merging, random merging. Okay, copy that. Random merging here and paste that in the count. This count is the metadata that includes the current iteration number. It's in its detail attribute. Okay, now this one will be the merging end. All right. So how do we do this? Well, for every primitive, there is a primitive number, right? One here, another one there. You can see they're all in a little random for now, right? But you know, everyone has a unique number, like an ID, right? So what we can do here is that we can, this is basically visualizing it. You can visualize the point number, you can visualize the primitive number. Okay, so we're gonna get one random faces and find a neighbor and merge them together, right? And we keep doing that until there's nothing to merge. Okay, so I'm gonna create a attribute wrangle here. Okay, connect that metadata to the second input. Okay, I'm gonna say get random. Okay, so what I want to do is run over the detail. This time we're going to run it only once. Detail means we're going to run this code only once, not over any individual primitive, but just once for this whole object. I need to know how many primitive I have. So int prim count equals to the number of primitives, and primitives, number of primitives of our first input. This will give me, this integer represent how many primitives we have, right? And we got a random number out of the range here. So we're gonna say int pick, a picking one, random picking one will be a number that's ranging from 0 to the primitive count -1. Now why do we -1? Because the count is counting from 1, right? 1, 2, 3, 4, all the way to the last. For the primitive number, it's gonna be from 0, right? So there's an off by 1 problem here, so we have to do that. We're gonna pick something that is fitting from 0 to 1 to a range of 0 to prim count -1. Okay, so what are we fitting? We're fitting a random number. Okay, a random number based on what? We could based on anything, like we can based on the prim count in this case, right? But we can also based on something else. So this is like the seed, right? In the mathematics of computer, random does not exist, right? Math gives you one and only result. So this random is kind of like a faking way to do random. It needs a seed. You give it the same seed, it does yield the same result. Okay, so we need to have the seed different for every time when we go through this. Okay, and luckily the reason we drag this guy in is that we can get the current iteration number. Okay, I'm gonna say int iter number will be equals to the detail attribute of, this time the second input. The attribute will be called iteration. and we're getting the first index of the attribute. This first index basically means that sometimes we're asking for attribute that is kind of like a vector, right? And the vector has x, y, z 3 values, and which one are you asking? So you have to type in a number here. But in this case, this is actually a abandoned variable, so it doesn't really get used to here. Okay, why do you even use an abandoned attribute? Because you wanted to keep the signature of the function the same, right? So you call the you call this function with the same 3 variables, so it doesn't go wrong that easy, right? This is kind of like for a uniform way of dealing with stuff. Anyway, so now we're getting the eternal number here. So we're basically getting both the primitive count and the eternal number involved, right? Just to be more flexible, we add another channel called seed, so we can tweak the seed to be a little bit different every time. Okay, so this is such a long line, right? And it's not over yet. So I'm gonna say we fit this into 0, 1, but this could be like a float number, right? It could be something like, oh, let me explain this first. We got a random number, right? From these 3 added together as the seed. Now this random number will be ranging from the description of this function is going to yield a random number from 0 to 1. Now we're going to fit that 0 to 1 range to a bigger range from 0 to the amount of possible primitive number we have. But this yield a float number, so we have to run it up. So rint in this case to run it up. Okay, all right, and then we have to cast it into int. If you ever use casting in C, C++, this is the same thing, even the same syntax. So this is almost like a C-style programming kind of like language. All right, we run this. Right. So now this peak number will be different every time when we run through this, and it's going to be a random number ranging from 0 to the possible primitive number we have through this entire geometry sheet. Okay, all right. So instead of doing an int, I'm going to say I add pick. Okay, now you can see we're getting a pick value in the details panel. It's 197. We can also click on this little plus sign here to add that seed attribute we're adding here. This channel seed is now the value here. So if we drag the seed, you can see how we're getting a different number, right? Because the seed is different, the random result is going to be different. Okay, that's a lot of coding and a super complicated line here. It's not that bad as long as you know what you're doing. But anyway, so let's break the video now. In the next one, we're gonna then try to talk about how we pick a neighbor, right? How we merge them together and how we keep on doing this until there's nothing to merge. Okay, see you next time.